All right, so area of parallelograms, triangles, and trapezoids. So we're going to go in that order. So we're going to start off with parallelograms. And I think you all already know. Well, actually, let's back up even further. Let's make sure that we know the difference between perimeter and area. Those two are always talked about at the same time. We've already talked about perimeter, so let's just make sure that we kind of remember. Perimeter, that's like, I always envision that as if you walked in that shape. So perimeter, I don't know, if you had like some kind of weird quadrilateral, if you literally walked this distance, the perimeter would be how far you walked. So you're just going to add up all the sides. So it is the sum of all sides of any polygon. So that's literally all you do. I just take the length of all the sides and I add them together. So if I just walked along the outer edge, perimeter, it would be how far I walked. Now area is different because area is now all the space inside the shape. So if this were a lawn, for example, and I was going to mow the lawn, you don't just mow the outer edge, right? That would be so convenient, but that's not how it works. You mow the whole thing. So I would put up a fence around the perimeter, but when you mow the lawn, it's the whole area, or it's the whole inside. So if I had the shape, area is everything on the inside. Okay, so area is simply the space contained within a polygon. Okay, it doesn't have to be a polygon, it could be any shape. Okay, so even you can find the area of a circle, you would just have to use its formula. You could find the area under a curve. Ooh, that's some fancy math. But anyway, for our purposes, when we're talking area today, we're going to be looking at just the space inside of a polygon. All right, so let's start off with area of parallelograms. And I'm telling you, you already know this, whether you know it because you know the area of a rectangle. But guess what? You know what? I'm even going to put area of all parallelograms. They're all the same as the area of a rectangle. What's the formula for area of a rectangle? Could someone tell me? Oh, I think I heard it. Did I hear base times height? I heard base for sure. So I'm assuming you did base times height. Yes, or length times width. It doesn't matter which one you say. I'm going to go with base and height because I really want, you'll see how it more applies to all of the other shapes. So, but length times width and base times height are the same thing. All right. So yes, you always learn it as the area of a rectangle, but it's actually the area of all parallelograms is base times height. That's it. That's all you have to do for it. Now, there is something important that you need to know about it. So first, let's jot it down. And then I'll talk to you about, because it does matter who's the base and who's the height. Okay, base times height. So if you don't know, that's the base, that's the height, obviously. I know this is old news, but just in case. Okay, all right. So when you have a rectangle to do base times height, it's really no big deal, because you just take this rectangle, right? And then the base and the height are just the two sides. So if this were 5 and this were 3, now you know, okay, well, the area of this whole thing is 15. Actually, let's throw in the units here too. If these are meters, take a look at what happens when I actually do this. Now, does it matter who's the base and who's the height? No. Because remember, I'm just multiplying, so it doesn't matter if you say 5 is the base and 3 is the height, or the other way around. It really doesn't matter. So I'm going to do 5 meters times 3 meters, and look what happens. Look what happens. Look at the units. Look, look, look. Obviously, 5 times 3 is 15, but look, you have m times m. That's why area, the answer to area is always in whatever the units are squared, because you literally are squaring the units. Meters times meters gets you meters squared. Do you see that? A lot of times we don't even write, like when we're doing the math, we usually don't even write the units. We just do the 5 times 3, and then you guys just know, oh yeah, area is always supposed to be units squared. But that's why. We don't just randomly make up these math rules just for funsies, right? There is a basis for them. And I know, yes, normally I don't write the little m's, to be honest with you. I just throw the m squared on at the end, but I want you to understand where that's coming from. It's not just make-believe. Okay, so I'm claiming that this is the case for, well, actually, well, gosh, I know I'm jumping around a lot today, but let's make sure that while we're talking about the units, let's make sure we note that. Units for area are always units squared, or square units. So you can write it either way. Units squared or square units, that's personal preference. So if you like go to, I don't know, if you go to Home Depot and you're buying flooring, you're going to see them pricing things as square units. So you'll see it written like this usually when you're out shopping. Buying carpet, that's all sold in square units. Usually it's square feet. When you're painting a wall, they talk about it in square units because you're covering a whole surface, right? So if you need to figure out how many gallons of paint you need to buy, you need to calculate the area of your surface, right? Oh, so fancy. All right, any Hoosers. So let's go back. All right, there's a rectangle, but I'm claiming that this works for all parallelograms, all of them. But here's the catch. So let me draw you just a regular old parallelogram. And I'm going to give you some numbers here. So, parallelogram, right? I'm going to mark it as such so we know that it is. Got it. All right, please pay attention because this is super important. You ready? The area of this thing is absolutely base times height. All parallelograms have that same formula, base times height. The problem is, if I told you, I don't know, let's say that the bottom is 10, and this side right here is, oh, who cares, 6. The area of this thing is not 60. What? Mrs. Sabia, you literally just said that you just do base times height. You're right, you do. The base is 10. The height is not 6. When was the last time you went to the doctor's office and they measured your height and you stood slanted like this? Never. That's not how we measure height. We don't measure height slanted. In order to be considered a height, it has to be perpendicular to the base. So if that were a 90-degree angle right there, then you'd be all set. And look, in a rectangle, that's why you can do this, because the base and the height are perpendicular to each other. But in this parallelogram, right now, you couldn't give me the answer for the area because you don't know what the height is. I have to give you the height. So usually how that's done is we usually draw, sometimes it's dotted, sometimes it's solid, doesn't really matter, but you're going to have something on the inside. Maybe it's there and they might put it in the middle. They could put this line wherever they want on the inside, but then it has to be perpendicular to the bottom. Okay, that has to be true. Now, this red line that I just drew, that's the height. So I might come in and tell you that that's now, I don't know, let's say it's 4. Now you can find the area. You're not going to use the 6 at all. The 6 means nothing to me here because I want to do the base times the height. The base is 10. The height is 4. I have no use for the 6. Yeah, so my answer in this case would be 40. I'm telling you right now, they're going to give you all 3 numbers, usually. So you need to know which 2 you're multiplying together. And it's always got to be the 2 that are perpendicular to each other, the base and the height. Area of this thing would be 40. And whatever my units are squared. So I'm going to have 4 times 10. So I get 40 units squared. If I don't put units on it, you can just write the word units. Okay, so be careful. I'm going to put a big star because it's super important that the base and the height are always perpendicular to each other. If they are not perpendicular, then you don't have the base and the height. Okay, so there are other formulas for some of the other, what do you call it, parallelograms. Square actually has its own formula. However, you can still use base times height. A rhombus has its own formula that will work for it, but you can also use base times height. You can use base times height for literally any parallelogram, okay? Any of them. So let me flip this page and we'll look at a couple more. So I mentioned a square. I don't like memorizing. I mean, you guys don't have to memorize because it's all up in notes, but even if it weren't, I don't like memorizing all these different formulas. Why? You don't have to. I don't memorize a separate one for the square. I'm still, if it's a square, I'm still just going to do base times height. What might be different is that if they tell you it's a square, they might only give you one side. They might just say, okay, that's 5. But, all right, well, if it's a square, then they're all 5, so I'm just doing 5 times 5. No big deal. So the area of this thing, I get 25. Let's do meters again. So even though they didn't list another 5, I know that they are all 5, so I know I get that 25 meters squared. Okay, I mentioned a rhombus. You know what? I'm going to draw you the rhombus in an interesting way so you can kind of see. Yeah, let's do this. So sometimes you're going to get one drawn like this. Okay, that doesn't look quite like a rhombus, but let's pretend that it is. So in fact, I'll mark everything and I'll tell you they're all 6, whatever. All right, so in this particular diagram, I don't have a height given yet, right? So normally I would come in and I would draw that dotted line on the inside, but I kind of actually don't really even have enough room to do that. So sometimes when the shape is so slanted, they'll actually put the height on the outside like this. So they just extend one side and then they put the dotted line over here. But it's still going to be marked as perpendicular. So now I still know that this is going to be the height of the shape. The base is still this. The base of the shape itself is just here. This isn't part of the shape at all, this red, right? My original shape is what's here in blue. The base of it is 6. And then the height would be whatever I tell you it is. What do you want it to be? I don't know, 3? Sure. So the area of this thing, even though all of these other sides are 6, I'm not doing 6 times 6. I have to do the base times the height, and the height is 3. Okay, so the area this time would just be 18 units. 6 times 3. square units. All right, so I'm even going to note that that thing is still the height. This thing here would be your base. Also, be careful of this. Sometimes we think of base as the bottom. It doesn't necessarily have to be the bottom. I just need the base and the height to be perpendicular to each other. Any side could be the bottom, right? Because I could just turn my page. I could turn my page however I want to change who's at the bottom. So base does not necessarily mean bottom. So, in fact, let me try and give you one where I'm sort of demonstrating that. Yeah, so say I gave you this thingamajiggy, and this thing was a parallelogram. So let me just mark it as such, so there's no question about that. All right, so, and then let's say I came in and I told you this was 8. This was 5, and this was, let's make that 4. Okay, find me the area of this thingy. I'm confused how I'm getting. Yeah. That's so funny. So 2 of you in the chat sent me the same wrong answer, and then you both realized. Yeah, that's so funny. Yes, so I had 2 people answer 24, but even if you use the wrong side, I don't know where 24 came from, but then they both realized that, no, it's 32. 32 is right. Yes. The 5 is just an extra bit of information. You're not using that for anything, right? The 5 is not the base or the height. The base is 8 or 4, I guess. You could think of it either way. But I would think of 8 as the base, and then the height of the shape is 4. I need the 2 that are perpendicular to each other. If it makes you feel better, turn your paper so that it looks like this. So if you want to have the base on the bottom, go ahead. I'm not going to stop you. But just make sure that whatever numbers you're putting into the formula are perpendicular to each other. So that's why the 5 is useless for me as I'm trying to find the perimeter. I mean, oh gosh, it would actually be useful for the perimeter. It's useless to find the area because I want base times height, and that's not either. So let me just jot down. This one we're doing the 8 times the 4. So we should get 32 square meters, square units, units squared, however you want to say it. Just make sure that you have the squared, or you're putting the exponent of the 2 on the end. Okay? Try and get in that habit so you don't forget. All right, so that's parallelograms. And now, did you know that the formula, I know you know the formula for area of a triangle, but do you know why it is what it is? Do you know it? I know some of you do, because I've already gotten it in the chat. Olivia, that's trapezoid. But without the part in the bottom. Triangle is just your very first part. So area of a triangle. Here it is. A equals 1/2 base times height. That's all it is. 1/2 base times height. And let me show you why. Did you know that any triangle that you can create, if you just take 2 of them, so duplicate that triangle. Let me do it. Hold on. I'm going to take any old triangle. Doesn't even matter. Let's do this one. I've got this one. Oh, no, I need to. Does it work? Yes, it does. Okay. Cool. There's one triangle. Let me duplicate it. Hold on. This is so cool. I don't even know if you know this or not. Maybe. If you do, great. If you don't, prepared. Get prepared for the magic of geometry here. Oh, for the love. Here we go. All right. So I have two triangles that are, oh gosh, I put them together in the wrong way. That one's got to go there, and that one's got to go there. Okay, two triangles, identical, right? See this? See this? Any kind of triangle you can make. This one happens to be obtuse. You could have done a right triangle, isosceles, who cares? Any triangles. Check this out. Watch. You ready? You ready? If you take one and you just flop it over and twist it, I've got to flip it this way. There we go. You can take them and flip it. Look what I just made. I just turned it into a parallelogram. Do you see that? It's a perfect parallelogram. No way. Way. Any triangle. Try it. Well, I know you don't have these thingies, but watch. I'll do it with an isosceles. So now if I had two greens and a pink. So there's one. Let me grab another green. Okay, so now I have two identical isosceles triangles, right? I can do the same thing, right? They match. You can flip it and, wait, how did I do that? Oh, here we go. Ta-da! Look, I've made a perfect parallelogram. That's so cool. I can't make it snap, but you see it there. So if you take basically any triangle is really just half of a parallelogram. That's so cool. So the area formula makes a lot of sense now that you know that, because it's just half of a parallelogram, any triangle. Think about it. A right triangle is literally just half of a rectangle, isn't it? That's so cool. I know. So the area formula totally makes sense. I still need base and height to be perpendicular. That will always be true. Anytime I'm doing any of these formulas with a base and the height still must be perpendicular. Always. Okay? All right. So let's take a look. We'll just do some easy ones. So here, let's say I had a base of, who cares, 8. And again, the height, even if I knew what these other things were, say I told you that this was 4, doesn't matter. That thing's not the height. The height has to be perpendicular to the base. So I'd have to do something like that. And now you could tell me, all right, well, that area would have to be 24 because 8 times 3, the 4 has nothing to do with it. 1/2 base times height. So don't forget to do that. Oh, it wouldn't be 24, it's 12 because I forgot the 1/2 part. Exactly what I told you not to forget. 1/2, my base is 8, my height is 3. Okay, so I'd get 12 there as my answer. Still units squared or square units, however you want to do it. Now the base and the height could come sort of in different ways. So you could get a problem that kind of looks like this. What if I did that? And I didn't give you anything in the middle. Can you find the area of this figure? I know I'm going to do 1/2 base times height, but yeah, as long as you have 2 of the sides or 2 things in there that are perpendicular to each other, you have the base and the height. If you really want, you can turn your paper so that the 3 is on the bottom like this, and now you have the base and the height. Yeah, so you can totally do this. The 5 is irrelevant. I'm just going to use the 4 and the 3. So in this case, that would get me, now who's the base and who's the height? It doesn't matter. It doesn't matter who you put in for B and who you put in for H. As long as they are perpendicular to each other, you just pop them in wherever you want. 3 times 4. So that's going to get me 6. Okay, so just be careful. Sometimes the base and the height are part of the sides. And the only other heads up that I need to give you about triangles is sometimes, again, the height, they put it outside the triangle. So if you had, usually it's with obtuse triangles, but I guess you could do it with anything if you really wanted. So if you had a big old obtuse triangle like this, oh gosh. Oh, I don't know why that's not coming out. Let me try switching to this pen. Actually, I just realized that I got new markers and they're still in the car. I'll have to go out and get them at lunch. All right, anyway, so here is a triangle like this. So if I tried to draw the height in here, I wouldn't be getting all the way to the tippy top. So you're going to see they're going to do the same thing. They'll extend aside and then drop the height kind of like that. Notice that you have to know that it's perpendicular. So they're going to note it. And then, I don't know, I'll say the height is 3 and the base is 9. And now you can find the area of this thing. Don't be fooled by me giving you other numbers. If I told you this was 12 and I told you this was 5, who cares? The only numbers I need are the 2 that are perpendicular to each other. The 9 and the 3. Okay, so the area of this thing, 1/2. Base is 9, height is 3. So what's half of 27? 13.5? Is that right? Double check me. Yep, okay, cool. So that's pretty much it for triangles. You're just doing 1/2 the base times the height because they're half of a parallelogram. That's so neat. All right, and then we only have one shape left to talk about, and that is the trapezoid. Okay, so I gotta turn the page. So hopefully you have all of this. Trapezoids. Oops, let's spell trapezoid right. Trapezoid area. This formula looks weird, but it's actually, here's how I like to think about it. It's the formula for area of a triangle. It's just altered a little tiny bit. So actually, before I write it, I want to draw you just a regular old trapezoid and talk about some of the pieces. Okay, and this works whether it's isosceles, not isosceles, it doesn't matter. So remember, in a trapezoid, you're always going to have one pair of parallel sides. Those are called the bases. The 2 sides that are parallel to each other. So this thing is a base, and then this thing is a base. So you actually have 2 of them. So what we do is we usually call one of them base 1 and the other one base 2. Doesn't matter which one you label as base 1 and which one's base 2. Doesn't matter. So I don't know, I'll just call the one on top base 1 and then the one on the bottom base 2. But again, it doesn't matter. You could swap them. Who cares? We just have these 2 bases. And then the other thing that you're going to need is, again, you need the height. And the height still has to be perpendicular now to both bases, right? So again, you're going to have something on the inside, and it's going to note that it's perpendicular. Now, I don't have to show that it's perpendicular on top and on bottom because these are parallel. So I only have to mark it in one spot because if that one's 90, that one's automatically 90. So usually they don't mark it, but it has to be marked at one of the bases. Okay, so this thing is still the height. All right, so now let's take a look at the formula for area of a trapezoid. And I'm telling you, it's just like area of a triangle, right? In fact, no, I won't do that. Okay. Area of a trapezoid. Let's put it, and you'll see how closely it resembles area of a triangle. It's still 1/2 base times height. It's just that since we have two bases, we just add them together. That's it. So it's 1/2, not just the base, but it's the sum of those two bases. And then you times it by the height. So it looks a little complicated, but it's not. It's just 1/2 base times height, but I have two bases to add together. Huh. That's all. Nothing too crazy. I'll even add, note how similar to area of a triangle. So if there does come a day when you do have to memorize this, it's not that much to memorize because you already know area equals base times height for a parallelogram. Then a triangle is just half of that, so that's not so bad. And now the trapezoid is the same thing. You just have two bases to add together. So let's see how this works in a problem. So any old parallelogram, doesn't really matter what it looks like. Parallelogram, my gosh. Trapezoid, any old trapezoid. Can be isosceles, doesn't have to be. Who cares? You're going to need, I'll give you a whole bunch of numbers. Maybe that's 6. Maybe this is 15. Maybe this is 9. And maybe this is 10. Obviously not drawn to scale. You could not find the area of this thing until I came in and gave you the height. So let's go ahead and do that. And let's say that that thing is 5. So if I want to find the area for this shape, I got to use my formula. 1/2 sum of those bases times the height. So let's pop all the pieces in. 1/2. Now again, it doesn't matter who you call base 1 and who's base 2. Just make sure that they're the two sides that are parallel to each other. So I'm going to need to add together the 10 and the 15 in there. And then I'll multiply it by the height. And make sure you pick the right number for the height. It's the one that has to be perpendicular. I'm not using the 6, right? That's not perpendicular. The 9's not perpendicular. The 5, that's the one I need. So before I do any calculating, that should be how everything sort of falls into the formula. All right, and now you just have to be super careful that you follow order of operations. Remember that you must do parentheses first. So 10 and 15 is 25. Now it's just multiplication. So now I can just grab Mr. Calculator and ask him what I get here. 1/2 times 25 times 5 is, I get 62.5. Square units. Units squared. Whatever floats your boat. And that's it. So let me give you one to try. Let's say this is 8. This is 12. Let's make these 7s over here. And let's say that the height is 6. I don't know. So go ahead, find me the area of this trapezoid. Okay, I'm getting some right answers in the chat. If you gave me 60, you are correct. Yes, yes, yes. So putting all the pieces together, 1/2 sum of the bases times the height. So I'll be doing a half. My bases are 8 and 12, the sides that are parallel to each other, and the height is 6. Those 7s are irrelevant. I don't even care about them. 1/2, 8 and 12 is 20 times 6. And now I just multiply that all together. So 1/2 times 20 is 10 times 6 is 60 square units. And I'm done. Well, that's not so bad. Okay, so I'm going to hop over to your homework real quick. So let me post it. So if you feel ready to go, you can get started. Give me just a sec. We are in V block. I always got to tell myself because I can't ever remember. Post. Okay, so homework 25 is on CUDA. It's ready to go. I will show you a few up on here for the video if anybody needs it. Okay, so the first part should be pretty straightforward. Just going to ask you for area of different types of parallelograms. So make sure you're doing base times height. Should be pretty straightforward. Then, okay, now here you have a triangle. They only give you 2 numbers, but luckily those 2 numbers are the base and the height. So make sure you're using the formula for area of a triangle, though, because this is not a parallelogram. So if you answer 80, you're going to get that wrong. You need to do 1/2 base times height. This should be on CUDA. So if you don't see it, hit refresh. This is homework 25. Okay, so you're just going to get a smattering of the different parallelograms. So if it's a parallelogram, you know to do base times height. If you hit a triangle, make sure that you adjust to 1/2 base times height. And when you hit a trapezoid, you got to do 1/2 the sum of the bases times the height. All right, so that's really the only difference. So just make sure you're paying attention to what shape you have. Okay, and I will say this. I don't love that the software has done this because I'm sort of a stickler for this. But so take this one for example. They don't come out and say that this thing is a trapezoid. You can assume that it's a trapezoid. Okay, so I hate that. It should say it, but it doesn't. So whatever shape it looks like, so I mean, obviously that's a triangle, but that you can assume it's a parallelogram, okay? So my apologies for their shortcomings on this because it really should say, I mean, this one you don't have to say it because it's marked. So that one I know it's a square, but ones like that, it's not marked as a trapezoid. So how do I know that it is one? Same thing here. This is not marked as a parallelogram, nor does it say that it is, but you can assume for this assignment that the shape is what it looks like. Okay, does anybody have any questions? All right, let me stop